Guys, we are back on another stream at exact 6 p.m. in the morning. So, guys, if you can see, oh, wait, let me just clear it out. Seriously, they cannot see this thing? I'm not sure. P.m. in the morning. Oh, they can see, they can see. Alright, it's 6 p.m. guys, it's -4. Oh my god, so भाई इतना गर्म दिल्ली 27 डिग्री. Anyways, guys, let's go to neat4.io roadmap. This guy is doing great, and we are learning from him. So okay, just so many questions, and we did a medium. I did it by my own. That was a crazy part, right? Oh, it's all logged. Is it all logged? What does that mean? Go to pro access. What's the pro access? One time payment. Hmm. I mean, instead of taking pro from here, I can do a pro from LeetCode itself, right? Ayo. Let's start. Length of last word. Okay, length of last word. You are given a string S consisting of word and spaces. Write down the length of the last word in the given string. A word is a maximum. Okay. Okay. So the simple logic which I can think of is reading it from the end and counting it till we get the space. Oh, but the space can be in the front as well. The space can be in the front as well. So in that case, this is a copy of this pure string. I can understand. Hmm. Hmm. So the best way, I think, what we can do, because there is a possibility that a space can be at the end as well. The space can be at the end as well. If is that is the case, then I have to start it from there. Otherwise, from the last element. Otherwise, from the last element, I can think of as the I can think of. Hmm. I can think of that I need to run a loop, but is there any better way? Is there any better way? No, but let me just implement what I know. If s of len s is equal to space, then how to do a back loop, man. Uh, or I can maintain two variables. I can maintain two variables in which I will be storing the position of this space, and as soon as I get the first position, I will replace it with the last position. Right, if I try to do it in this way, uh, position 1 is equals to 0, position 2 is equals to 0. For I in range length s, for I in range length for I in range length of s, if I is equals to space, then position 2 is equals to position 1, and position 1 is equals to I. Return position 1 minus position 2. So if 0 1 2 3 4 5 6 7 8 9, so this is at the 8th, then 9 10 11 12 13 14. One simple thing that I can, or one edge case that I have to include, if s of length s if length of s is not equal, इसी में मैं include, I can include it in the same row. If I is equals to space and I is not equal to length of s. No. If oh my god. Oh my dimag. Ah. This is the case where I will be at the very end. Hmm. Hmm. Then this is the logic. It will be position 2 minus position 1, and position 1 will be equivalent to the I, right? If I is equal, hmm, so I can check directly if the length, hmm, if at that specific thing, so it made me tough here because I'm not able to do the reverse of a string. Hmm. Let me use Gemini to use the logic. Alright, Gemini, I'm trying to solve this problem using the by reversing the string, and if the first element while reversing the string is a space, then I will look for the second element in the space and I'll do the difference. If the first element is not a space, then I'll just look for the first space while reversing. How can I write the logic? Ignore ignore my current approach because that is I am trying to use another method. Just suggest me the response based on what I just explained. how this solution is O of n if we are looping it twice. I see. I like this approach. So basically here we defined I and length is equals to, and length is equals to total length minus 1. I की value like we defined the last index, because it starts from 0, so we defined the last index, and here length we defined 0. So while sfi is blank, we gave it the value minus 1 when yi is greater than, because we are traversing from the back, so until I is got it. Was not a good one, man. It's, this is the end. Hold your hand till the valid word square. Let's see. Valid word square. Okay, we'll do it here, baby. No problem. Fuck. No worries. Let's solve what is free. Fucks up. Number of senior citizens. Okay, that's for us. You are given a zero indexed array of string details. Each element of details provides information about a given passenger compressed into a string of length 15. The system is such that the first 10 characters consist of the phone number of the passenger. The next m characters. The next character denotes the gender of the person. The following two characters are used to indicate the age of the person. And the last two determine the seat allotted to that person. The passenger at index 0, 1, and 2 have age 75, 92, and 40. Thus, there are two people who are over 60. There are two people who are over 60. Okay, I have to return all the number of people who are above 60. So basically, I have to access the uh, 11th and 12th index, and then I have to convert that into an int. So access 11th, convert it to an int. Age is equals to, okay, count is equals to 0 for I in range details. Age string is equals to I from 11th till 13th, so 11th and 12th. So count if int of this thing is greater than 60, if int of this thing is greater than 60, then count plus 1, then count plus plus, else false. At the end, return count. I'm bet sure this is gonna be wrong. 100% sure. The syntax itself is wrong. I know. But let me just check what is wrong in this syntax. What is wrong in this syntax? Oh, one thing that I understand is that here it has to be len of details. For sure. Hmm. Oh my god, I did not start at the clock. To some given an array of integer nums and an integer target, return the indices I and j such that this is a tricky one. I have to return the indices whose element sums the target. Focus, focus, focus. Given an array integer of nums and an integer target, return the indices I and j such that the num of I and num of j is equals to target. 7. Oh, this is a tricky one. How can I do it? How can I do it? How can I do it? If I selected one index, then I will iterate through the rest of the index. That's one. But that is gonna be an n square because I have to do it for the other element. No, but then I have to do it from there to the other element because I have checked this one with the this already, right? So no, I cannot. I know the solution, but I need to check. We can check every pair of different elements in the arrays and return the first pair that sums up the targets. This is the most intuitive approach, but it's not most efficient. If we can check every pair of different elements in the array and return the first pair that sums up the target. This is the most intuitive approach, but it's not most efficient. Sorting wala is a nice one. Just create a copy of the array and sort it. Initialize 2.2 to the 1 and 9.
Let's solve LeetCode 1 two-sum, the most popular LeetCode question. So we're given an input array and some target, in this case 9. And we want to find the two values in this input array that sum to 9. So in this case, it's 2 and 7. Now we want to return the indices of these two values. So the index of 2 is 0, the index of 7 is 1. So we return 0 and 1. We're guaranteed that there's exactly one solution, so we don't have to worry about not finding a solution, and we don't have to worry about multiple solutions. Now the most intuitive way to solve this problem is basically just check every combination of two values and see if they can sum up to our target. So we start at 2, we check every combination we can make that includes 2. So we scan through the remainder of the array 1, 5, 3, and check if any of those numbers added to 2 sums to our target 4. In this case, none of them do. So next we can repeat the process. Let's check every combination including 1 that sums up to target 4. So we scan through every element that comes after it, 5 and 3, and we find that 1 added with 3 sums up to our target 4. Notice that we didn't have to check the values that came before 1 because we already checked the combination 2 and 1 when we were up over here. Remember when we checked every combination with 2? So we didn't have to repeat that work down here. We only had to check the numbers that came after 1. So the runtime of this algorithm isn't super efficient. This is basically brute force. We're going through the entire array of length n, and we're going to do that worst case n times for each number. This means that the overall worst case time complexity will be O of n squared. So can we do better? Now the thing to notice is that for each number, for example, 1, the value we're looking for is the difference between the target and this value 1. So we're looking for 4 minus 1, which is equal to 3. So that means this is the only value we can add to 1 that'll equal the target. So we don't have to check every number, we just want to know if 3 exists. Now the easiest way we can do this, the most efficient, is by making a hash map of every value in our input array so we can instantly check if the value 3 exists. Now let's try the same problem, except let's use a hash map this time. Now in our hash map, we're going to be mapping each value to the index of each value. So the index of 2 is 0, the index of 1 is 1, the index of 5 is 2, the index of 3 is 3. So in our hash map, we're going to be mapping the value to the index. Now we could add every value in this array into the hash map before we start iterating through it, but there's actually an easier way to do it. If we added the entire array into the hash map initially, then we would get to the value 2 first, right? We would want to check does the difference between target 4 minus this value 2, which is equal to 2, exists in our hash map. And we would find that 2 does exist in our hash map, but we're not allowed to reuse the same one, right? Because they're both at the same index. We can't use the same value twice, so we would have to compare the index of our current 2 with the index of the 2 that's in our hash map. There's actually an easier way to do this though, and it's a little clever, and let me show you how to do it that way. So doing it this clever way, initially we say our hash map is empty. So we get to the value 2 first of all, right? And we want to look for the difference 4 minus 2 in our hash map. Our hash map is empty, so we don't find 2. So then, after we visited this element, then we can add it to our hash map. So now that I'm done visiting it, I'm going to move to the second element 1. Before I do that, I'm going to add this value 2 to our hash map, and the index of this value is going to be 0. Now I'm at 1. I'm looking for 4 minus 1, which is 3. I see 3 isn't in our hash map, but it actually is in our array. So what's the problem? Well, for now, we're going to say we don't find a 3. So we add 1 to our hash map. The index of this 1 is 1. And now we move to the next element, 5. We check, does 4 minus 5... 4 minus 5 exists in our hash map, that's negative 1, so no it does not. Then we add this 5 to our hash map, and its index, which is 2, and we move to the last value in the array, 3. We check does 4 minus 3 exist in our hash map. Now that's 1, so we see it does exist, right? Right over here. The value exists, and its index is 1. So now we found our two values that sum to the target, and we want to return their indices, which are going to be 1 and 3. So with this algorithm, we don't have to initialize our hash map. It can be initially empty, and then we can just iterate through this array in one pass. Now, the reason the algorithm can work in that way with just one pass is this. So let's say we had a giant array, right? We know for sure that there are 2 elements in this array that sum to our target, right? We don't know where they are. They're at some arbitrary location. When we visit the first one of those elements, our hash map is only going to be this portion of the array. It's only going to have the values that came before the first value. So we're going to notice that the second value that can sum to the target is not going to be in our hash map yet. But once we get to the second value, our hash map is going to be this portion. So every value that comes before this, right? So we're going to be guaranteed that once we visit the second element that sums up to the target, we're going to be guaranteed that the first one is already in our hash map, so we're guaranteed to find the solution. Now, since we only have to iterate through the array once, and we're adding each value to our hash map, which is a constant time operation, and we're checking if a value exists in our hash map, which is also a...
इसका explanation भी भाई tough है. Anyways, I guess I'll stop now today. I guess I just solved 1 question or 2 questions. How many questions I solved? I have to be more attentive. Today I solved 2 questions, which is good. So on an average, I'm solving 2 questions. It's wow, this is so bad. All right, so I'm gonna end today's stream, and we'll connect tomorrow.